Welcome to Math 1314. This is section 6.1. We're looking at what's called the matrix method to solve linear systems of equations. Now, many students find this confusing at first, so take your time, don't rush, it will come to you. So let's see what all this means. So here's our system of equations. First off, we write it as a matrix. Now, this is our matrix over here. And what is a matrix? Well, it's a box, got two square brackets on the two sides. And what's inside, I've got, here's the equals. Now I have this vertical line. And now I just grab all of the coefficients, 2, 1, 5. See, 2, 1, 5, minus 1, minus 1, minus 3. And so we just list them in this array of numbers, and we call this a matrix. Now, our goal is to try and take the matrix and make it where it looks like a 1, a 0, a 0, a 1. Where there's ones on this diagonal downward and there's zeros in every other place. And then I put here on this side the answer for x and the answer for y. Let's see why that would be the case. Well, let's see, 1x, that's this 1, plus 0y equals the vertical line, answer x, and so you see 0y is gone and x is this thing that would appear on the right hand side. And similarly, 0x plus 1y, the thing that appears here would be the answer for y. So if we can make our matrix look like this, then the answer is going to appear on the right, and we can just read it off. Now, if our matrix gets bigger, where we had 3 equations, then it looks like 1's down the diagonal and 0's in every other place. And if that's possible, we're going to get an answer for x, an answer for y, and an answer for z on the right hand side. Now, how we get those numbers, and we'll come back to this many times, there's an order to doing it. I'd like to get a 1 in this top left first. I want to use the 1 then to make a 0 under it. Second. Third, I'd like to get a 1 here and then use that 1 to make a 0 last. And so again, the basic idea is somehow to use 1's to make 0's. And the order is first, second, third, last. Some terminology. All right, so this top row is called row 1, abbreviated as R1. This row is row 2, the second row, as R2. So let's see what kind of operations we can do. And these are called row operations because we're operating on rows. So if for whatever reason I'd like to swap 2 rows. So in this case I'm going to swap row 1 and row 2. Well, I'll just swap them out. 1, 2, 5 now is the top row. And 2, 3, 1 is the second row. And the interesting thing is it doesn't affect the answers. The answer for x and y still are going to appear in their proper position. The second thing I can do is, if I want, I can multiply any row that I like by any non-zero number. So I'm going to take row 1 and multiply everything by minus 2. All right, so minus 2, minus 4, minus 10. And if I can also add two rows together. All right, so here's row 1, here's row 2. I'm going to add row 1 and row 2, and I'm going to make a new row 2. Okay, well, let's see. Minus 2, add 2, 0. Minus 4, add 3, minus 1. Minus 10, add 1, minus 9. So those are our only operations that we can do on rows. And so essentially I'm trying to combine those three operations to make ones and then use the ones to make the zeros so that we go from our start off matrix to one where I can read off the answers. Okay, well, let's try. So here's my initial system of equations. I grab all the coefficients, minus 4, 11, 58, 1, minus 3, minus 12. I want a 1 in this top left position, and I'm noticing I can just swap row 1 and 2, and I'm going to get a 1 there. Okay, that's a good start. So now, I want to use this 1 to make a 0. Now at this point, don't worry about the rest of this stuff. If it helps, cover it up with your hand. The only question I need to ask is, what would I multiply by 1 so that when I add it to this minus 4, I get 0? Well, the answer is 4. 4 times 1 is 4, and 4 add a minus 4 is 0. So what that means is I'm going to take 4 times all of row 1, add it to row 2, and make a new row 2. Now let's see, 4 times row 1. I just multiply everything by 4. So 4 minus 12 minus 48. We're adding that to row 2. All right, let's scroll up here. Row 2. And so now I'm going to add them up. All right, so 0 minus 1 and 58 minus 48, 10. And that's my new row 2. And you can see it. It's sitting right here as a new row 2. Now, row 1 did not change. It just did this multiplication temporarily so that I could create a new row 2. All right, well, that's good. I got a 1, got a 0. I'd like to have a 1 there. Well, that's easy. I can just multiply the entire row by negative 1. All right, so if I do that, I have 0, 1, minus 10. So we're almost there. So now I want to use this 1 to make a 0 above it. Same deal. Ignore the number on the right, ignore the thing on the left. Simply ask yourself, what would you multiply by 1 so that when you add it to minus 3, you get a 0? Well, the answer is 3. 3 times 1 is 3. 3 add minus 3 is 0. So I'm going to take 3 times row 2, adding it to row 1, that's where I want to make a 0, and I'm going to create a new row 1. So 3 times row 2, 0, 3 minus 30. Row 1 is 1 minus 3, 12. Add them up. Let's see, I get a 1, I get a 0, and I get a minus 42. And that's my new row 1. And we're done. It's just that simple. I've got 1s on the diagonal, 0s every other place. So This is the answer for x, and this is the answer for y. And if you plug them back into the original equations, they should work. Now, question 2, we have to modify things just a little bit. And the reason is, and you'll see in a moment. So first off, I make my matrix. I grab the coefficients. A 2, a -7, a -41, a 3, a -9, and a -51. Now, I'm looking for a 1. Well, it's not as easy as the first question, where I could just swap out the rows. They might say, well, you can make a 1, divide the first row by 2, or divide the second row by 3. The problem is, if I did that, I'm going to end up forcing a fraction. I'd really rather avoid fractions if at all possible. So the strategy is modified in this way. I'm just going to use the numbers I have to make a 0. So how would I do that? Well, I need to multiply something by 2 plus something times 3, and I would like to make a 0. Well, my strategy is this. I'm going to take 2 times -3. And then 3 times 2. That'll give me -6 plus 6 to give me a 0. So that's -3 times row 1. Alright, let's see if I can get row 1 back in the picture. Maybe not. Maybe make it a little smaller so we can see it. So here's row 1. I'm multiplying that by -3. So -6, 21, and since it's by -3, a 123. And then 2 times row 2, so multiply 2 all the way across. Alright, let's scroll back down now that we can see what's going on bigger. Alright, and so we're down to here. And so we're going to add these up. I do get a 0, a 3, and a 21. So look, I used the 2 and I made a 0. I'd like a 1 there. Now, is that possible here without making fractions? Well, yes. I can take row 2 and divide by 3. So 3 divided by 3 is 1. 21 divided by 3 is 7. That's good. I got a 1. Now we're back to our normal game of using the 1 to make a 0. Well, that's easy. Multiply this by 7. 7 times 1 is 7. 7 add a -7 is 0. So I'm going to take 7 times row 2. So 7 times row 2, 0, 7, 49. Row 1 is 2 minus 7 minus 41. Add them up and I get my new row 1. Now notice all I have left are things on the diagonals, zeros and other places. If I made a fraction at this point, it wouldn't make any difference because I'm done. I don't have to do any more adding. But in this case, we get something easy. I just take row 1 and divide that by 2. And so what I end up with is 1, 0, 4, 0, 1, 7. Here's my 1's on the diagonal. So answer for x is 4 and the answer for y is 7. And you can plug them back in. I plug them back in to actually show you that if you plug in the 4 and the 7 into both equations, you do actually get -41 and -51. so it does work. So if you can get a 1 easily, do so, because it makes things easier. If not, we're stuck using the numbers that we have. All right, in question 3, we have this giant 3-equation, 3 unknown system of equations. So I carefully grab all of the numbers. -2, -9, 14, 37, 1, 5, 4, 3, -5, 2, -2, -6. So go carefully, because you don't want to make a simple copying mistake. Here's our vertical line where the equals was. I notice I do have a 1 there, so I'm going to take row 1 and 2 and swap them out. Alright, I have a 1. So my plan at that point is going to be to use this 1 to make a 0 there and there. How do I do that? Well, 2 times the 1 would make that a 2. 2 add -2, 0. That's good. 5 times row 1, make that a 5, add a -5 is 0. So 2 times row 1, so all the way across by 2. And again, go carefully, it's very difficult to find your mistake. Here's row 2, add them up, I get 0, 1, 22, 43. Alright, so there was our first plan. Here's our second. So I'm taking 5 times row 1 and adding that to row 3. So 5 all the way across by row 1. Here's row 3. And again, I'm checking carefully I didn't copy something wrong. So add them up, 25 and 2, 27, 20 minus 2, 18, 15 minus 6 is 9. Okay, so now I just put everything back in place. So I got a 1, I have 2 zeros, that's good. And look, I've even got a 1 in my next position that I want. And so the game continues. I need to use this 1 to make 2 zeros. Alright, well, how am I going to do that? Well, I need a -5 to make that a 0. I need a -27 to make that a 0. Alright, so I'm going to take -5 times row 2, so -5 all the way across. I'm adding that to row 1. That's where I want to make a 0. Alright, so add them up. I get a 1, a 0, a -106, and a -212. And that's my new row 1. Let's see, I need a -27 to make the thing in row 3 a 0. Alright, so -27 all the way across, some big numbers. And add that to row 3. Again, some fairly big numbers, don't panic. And that's my new row 3. Alright, and so I put all that in position. So where are we at? Got a 1, 2 zeros. Got this 1, a 0 above it and below it. I'd like to have a 1 here. Well, let's see. What if I divide this whole row by -576? Yes, it turns out it's a nice number. And I do get a 1. -1152 divided by -576, and we get a 2. Alright, so we're 2/3 of the way done. All I need now is to make a 0 there and make a 0 above it. So I need a -22 to make that a 0, and I need a +106 to make that a 0. Alright, let's do it. And so, minus 22 all the way across. Add that to row 2. So there's my new row 2. 106 times row 3. All right, here's row 1. Add them up. And we get, finally, here's our ones down the main diagonal. I've got zeros every other place, and so I can read off. X is 0. Here's X. Y is minus 1. Z is 2. And plug them in and make sure they actually do work. And they do actually work. All right, so getting ones down the main diagonal is a goal. And if we do that, then we can read off our answers on the right hand side.